Now, it's my very great pleasure to introduce our speaker tonight, Steve Reece. Steve is a chartered mining engineer and a fellow of IOM3. He's currently the acting siting and engagement director of RWM Limited, that's Radioactive Waste Management Ltd. And over the last 25 years or so, he specialized in the field of using underground void space for storage of and disposal of materials. After graduating from Cardiff University, Steve worked in the South Wales coalfield, where he held a number of supervisory and management positions, including those of colliery manager at Trelewis Drift and at Deep Navigation. He moved to the Durham coalfield in the early 90s, where he became a member of the current Mining Institute and met many of the people joining us tonight. He was manager at Easington Colliery and lived just outside Durham. After a short period in a logistics role, he returned to mining and moved to Winsford, to the rock salt mine in Cheshire, where he was mine manager and chief mining engineer for nearly 15 years. During that time, he was instrumental in developing new business to use the very high quality void spaces there from the large scale room and pillar mining for the new business of storage of documents and hazardous wastes. Over the last 10 years, Steve has focused his career on the strategic use of underground void space and worked on the UK's Geological Disposal Programme for high activity radioactive waste. And he's also spent a lot of time working in Australia on feasibility studies on geological disposal facilities for hazardous wastes. And he's going to be joined tonight by his colleague, Bruce Cairns. So I'm going to hand over now to Steve to deliver his lecture on the geological disposal, delivering the nation's largest environmental project on radioactive waste. Over to you, Steve.
Thank you, Mr. President. If I may just get a sound check, we're still okay? Great. And I'm going to pop a presentation on, so just bear with me for 1 second. And hopefully just check that's coming through to you at your end. Excellent. Thank you. So yes, thank you so much for the introduction. It is an absolute pleasure to have accepted that invitation. Let me just get this clicking over. And when I was invited, I think Derek actually contacted me, and you know, Derek, we were reminiscing. I think we go all the way back to middle 1980s down at Trelewis Drift. I think was the first time we met down in South Wales, and it obviously brought back a lot of very fond memories about the time that I spent in the Northeast and in the building. So I thought I would take us into the building tonight. And I recall standing at the lectern, and I think it was in 1991, because I gave a paper on Easington Colliery, and I think Derek probably was president then. It was either Barry or it had handed over to Derek. And I was looking at the photographs on the wall, and I can see Barry there, and I suspect Derek is just tucked around the corner here on the alcove. So yeah, many happy memories, and I'm so delighted to hear of the work that's being done in the building and the plans to reopen in due course. And it's just a shame that we're having to do this virtually tonight rather than in person. I was very much looking forward to coming up. I think it was in March I was due to come up to give this talk. But anyway, thank you. So let me move on to the topic in hand, and want to talk about radioactive waste management, but particularly geological disposal, and the programme that I've been involved in for the last 10, 11 years. And Rick introduced Bruce Cairns. Bruce Cairns, who's on the call with us tonight, is Chief Policy Advisor at Radioactive Waste Management. Bruce has a longer history than I on this. He's worked both in government, worked within RWM, So depending on where our discussion goes tonight, because I'm going to cover quite a broad range of topics, Bruce will come in and add to the discussion, and we can have a bit of an open debate. So why are we even talking about geological disposal? Well, as I think most people will realise that nuclear technology has been, a part of our lives in this country for more than 60 years now, and whether that be through power generation, health, defence, it has created radioactive waste. That is a fact of life. And the image on the right-hand side of the screen is just showing locations around the country, around the UK, where radioactive waste is currently being stored, and some of this destined for ultimately for geological disposal. So it's a key point that when we are talking to people, just to emphasize that this isn't a theoretical issue. This waste exists. It exists now. People have different views, but the UK has had taken a lot of benefit in many fields from this. So there is almost a sort of a moral imperative on us to actually do something with this waste, to manage this waste properly. And of course it is being managed and safely stored now, but because of the unique nature of radioactive materials, some of it needs to be managed for very, very long time scales. So what do we do? Maintain the status quo, keep using storage, replacing stores, or do you move into geological disposal? And I'll come back to that in a second. But by maintaining that storage, really what you're doing is you're really just extending the risk and the cost, and you're really passing that decision on to future generations. And I think the view, and I very much subscribe to this view, that I think it's our responsibility to actually actively manage this for the long term. And I think that's really where geological disposal comes into the fore. So radioactive waste comes in many forms. One of the classifications, and I think it's an important differentiator just to explain where geological disposal, deep geological disposal, fits into the overall picture. One of the classifications is it low, intermediate, or higher activity waste? Now, lower activity waste, low level waste, makes up the vast majority of the waste that we need to deal with in the country. As you can see from the slide, 90% of the total volume. And most of that is treated, it's reduced in volume, and it is either disposed at the low-level waste repository in Cumbria, and in some cases it goes to specially licensed landfill sites. So if we think of that as the sort of majority of the waste by volume. However, intermediate wastes and higher activity wastes, they're not really suitable for disposal at those existing facilities. So we need a different solution. And in terms of this higher activity waste, just in terms of volume and scale, broadly speaking, what we call the inventory for disposal, when packaged, comes to about 750,000 cubic metres. And I know I'm talking to the Northeast and a proud football heritage. So we chose to use the Wembley Stadium analogy tonight because I know Sunderland and Newcastle supporters will have made several visits there. Maybe not as many as me as a Liverpool supporter, but I know that you'll have been there several times. So that's just the scale, about 2/3 of Wembley Stadium. And if you are interested in finding out more about this, we have specialists that can talk to you. but we publish, UK publishes its radioactive waste inventory, and that's updated on a regular basis about every 3 years, and there is a link in this presentation that will be available after. So I'm not going to go through all the words on this slide. This is just sort of for future reference and points. But I guess the key issues are that, you know, in common with sort of many countries around the world, and it underpinned by, you know, sound scientific advice, the UK has concluded that, you know, deep underground disposal is the right thing to do. So hence the government or governments have adopted those policies, and I'll talk a little bit about the policy in a second. So for those higher activity radioactive wastes, it's to dispose of them safely and securely in a geological disposal facility. The acronym that tends to get used is GDF, Geological Disposal Facility. So apologies if I slip back into GDF at some points. And you know, this really follows the recommendations that Quorum made when they first looked at this, and Quorum are still active, and I'll mention the role a little bit later in the presentation. I think it's fair to say and acknowledge that Scotland does have its own policy, focused primarily on surface storage, but the Nuclear Decommissioning Authority, our parent body, work with Scottish Government to help to make sure that the radioactive waste in Scotland is also managed safely. And the bottom bullet point, just acknowledging that we are part of, you know, we were formed, although we go back and have a sort of previous history, as Radioactive Waste Management Ltd, who I'm representing tonight. We were actually formed as a limited company in 2014 as a wholly owned subsidiary of the Nuclear Decommissioning Authority. So just bear with me 1 second. I just wanted to see if I could move this little image. Yes, I can. Just excuse me a second. Thank you. So I mentioned the policies and a couple of key documents, and again, we can help you with these references if that would help. But UK government and Welsh government have their own policies. They're very, very similar. There are some subtle differences which I won't go into tonight, but fundamentally they're similar. But this is a really important point, and I'll probably say this a couple of times during the evening. This is a consent-based approach, and it's really about RWM as the developer working in partnership with communities to identify a suitable site and a willing community. So very much a sort of a twin track, which I'll talk and unpack that a little bit in a minute. I think it's also important to register that geological disposal, or GDF, is a nationally significant infrastructure project. In terms of its permissioning, it goes through the development consent order route. This little image here is just the front cover of the national policy statement, so sort of sets out need, principles and the requirements and things that the planning inspector will consider when various applications are made. And we are a nationally significant infrastructure and require development consent orders for our boreholes. So if we put that into mining parlance, the sort of exploratory phase, we call it site characterization. They require consent orders, as does the construction of the GDF itself. I would also commend these documents to you. So these are published by ourselves. We have a community guidance document. These are just the English versions, but we do have them for Wales and in the Welsh language as well. And the community guidance document really explains the route to working in partnership with the communities, leading up to something called the test of public support, which I'll come back to in a second. So think of that as the willing community strand. And this document here is the site evaluation document, and really explains our approach to evaluating sites. It's how will we determine that we feel that the site that we are examining is actually suitable. So those are the two sides of the equation, but totally interlinked. They're not separate strands, but totally interlinked. And in the middle, I've just pulled up one example of a really good resource. This is the National Geological Screening, and this is just happens to be one of the sub-region reports. And British Geological Survey did some enabling works prior to the policy being launched, and we use this quite a lot in our early works. I'm just going to put my pointer on because it'll save me. Yeah, there we go. How does geological disposal work? So it's a combined system. It's a system of engineered barriers and natural barriers, the geological barrier, working together. And what this is fundamentally seeking to achieve is to isolate the radioactive waste and contain the radionuclides for sufficient time for them to decay and to protect the environment and people from the adverse effects of radiation. So that's what radioactivity, that's what this is about. And there are a series of components. I think the first thing to emphasize is that we're only talking about solid waste. This is not putting liquid waste into the ground. This is all about solid waste. And it will be encapsulated in some form. For example, could be concrete, could be glass, grout, cement. And then it's placed then in a robust container. It could be a steel container, concrete container. Those that have followed the Swedish program will know that they have a high reliance for their spent fuel on the copper canisters. And then that container, which is a solid container with no void space in it, is surrounded by a backfill material, often a bentonite clay, not always, but often a bentonite clay. It depends on the host geological environment. And then it's placed, that waste is taken underground via either drifts, inclined tunnels, vertical shafts, and placed in disposal tunnels or disposal vaults. Disposal vaults tend to be for the intermediate level wastes. Disposal tunnels, we use that term just to differentiate where if we dispose of spent fuel or vitrified high level waste, they would go into disposal tunnels. But of course, above all of the engineering, this is placed in a suitable geological setting, which can be a variety of rocks, and I'll come back to that in a second. But we have a host rock, and we may have overlying rocks. In some circumstances, the host rock and the overlying rock may be one and the same all the way to the surface. At typical depths of a minimum of 200 meters, we say nominally down to 1,000 meters. And this is called the multi-barrier approach, so often called the Russian doll approach. So I mentioned in my opening remarks about this being a sort of an internationally recognised method of managing higher activity waste. And I think it is generally that those countries that have programs have by and large concluded that geological disposal is the most appropriate approach to managing these wastes, is the safest solution. And I think one of the great strengths of our organisation, Radioactive Waste Management, is that because this is a sort of a non-commercially competitive environment, I mean, clearly there are commercial aspects to it, but broadly speaking, it's sort of a non-commercially competing environment. There is excellent collaboration, and colleagues at RWM have over many years established a very wide network. So there's a lot of information sharing, a lot of technology development that we're able to help each other and work together on. So just a bit of a map. And this slide, I always like this slide. It's just a series of examples from around the world of either underground rock laboratories where experimentation, in some cases full-scale experimentation, is taking place, or in the case of Finland and in the USA, actual preparing for disposal activities and disposal taking place. So I think one point, and I'll come back to this in a second, but I chose these examples because they pick up a variety of geological environments, and this is important, that it's not just some people often think it needs to be in a granite or a higher strength rock or so on, but we've got examples here in sort of granitic higher strength rocks, salt in evaporites, clay rocks in Switzerland, again back at SKB at Espoo, which is in a granite, and France again in a sedimentary rock. So a variety of geological environments can be flexed by modifying the engineered barriers. So I'm going to spend the next couple of slides now taking us to the community side of this, and I'm going to then come back to some of the technical aspects, but I think this is really so important, and this is why I generally tend to lead with this when I'm talking about our project. We say consent, and it really boils down to that communities have a lot of choice in this. They can choose if they want to be part of the process. It's not an enforced process. It is a genuine choice for the communities. And they have their say. Fundamentally, there are many protections, in terms of things that we have to do with regulators and achieve development consent orders, and they all have consultation elements in them in their own right, and the production of safety cases. But ultimately, the community has a say, and it's through something called a test of public support, and I'll come back to that in a second. We're at a stage where the policy in England and Wales has been live for about 18 months, this current policy just a little bit longer, and it's open to anybody to start a conversation with us if they are interested in finding out more. We'll do some initial work with them, and then if they want to find out more, we would look to form a working group to open up that engagement with the wider community. Want to be in a very open, transparent way, and having gone through the sort of working group stage, I'll come back to that in a second, we would move on to a community partnership. Now, this is the first stage where the process requires the participation of what's called a relevant principal local authority, so a district or a county or a unitary authority. So it's another level of community representation, elected representation. But I said that communities have control. There is a right of withdrawal from the process as we move forward, and ultimately the community that would host the facility, called the potential host community, need to give their consent to hosting that facility through a test of public support. And that needs to be done before any final decisions can be made on the site to go forward to construction. So a lot of control for the community. So what is in it for the community? I mean, people sometimes have, you know, an initial reaction to say, "Oh, radioactive waste, you know, oh, you know, scary," and so on. But when we find that when we get into conversation, it tends to sort of flow down this channel. I mean, first of all, people recognise, and you know, if ever there was a time to recognise the need for high quality, multi-generational jobs. I mean, it's so much been brought home to us by the troubles that we have at the moment. And you know, a GDF, if it operates for the duration that we anticipate, you know, it'll be for over 100 years. It could be even for longer than that. So this is a multi-generational infrastructure investment project. So obviously as well, you know, I think we all know that big industry attracts other things, and it, you know, it's going to act as that catalyst or that nucleus to provide, you know, a major uplift and bring other infrastructure, bring benefits to the supply chain, supporting industries, education and training to the community that hosts it. So there'll be the direct jobs and there'll be the pull-through benefits. In terms of wider other benefits, during the sort of fact-finding stages and site evaluation stages, the government has committed in its policy to fund investment funding of £1 million a year. When we're in the early stages, rising to £2.5 million a year when borehole drilling is taking place. And this is really investment funding to the local community for appropriate projects, just to start to get these funds flowing. But what the real prize is here, as well as the jobs and the indirect jobs and benefit that comes, the real prize is for us to work in partnership with the community to develop their vision, which in turn will underpin the long-term significant additional investment that the government is committed to. So in the policy, you will see an absolute commitment from the government to provide additional. So that could be a multitude of things. It could be additional transport infrastructure. It may be something to do with connectivity. It may be power supply. It could be transport links, it could be education, it could be health, a multitude, flood defences and so on. So a really wide range of things that you wouldn't necessarily directly link to GDF, but the government have committed to recognise that contribution that the host community would be making. So I think this slide just sort of sums it up. It's really about jobs and skills. It's supporting the community, and it's bringing infrastructure investment to the locality. So this graphic is actually in the Working with Communities policy, and I think it's a helpful graphic because there's a lot of information on here, but it sort of tells the journey. It talks about the stage that we are at the moment in a number of places in the country where we have interested parties who are talking to us. Those conversations are taking place in a confidential space, which is right, because before we go into a public-facing working group, you know, I think the interested party needs to be sure that there's merit in the area. We certainly, as radioactive waste management, want to be sure that there are some prospects, but we are looking to transition, and in fact, I think it is in the public domain that West Cumbria, particularly Copeland Council, have said quite recently that they are seeking to enter into a working group stage with us and some other interested parties to start forming this group. But we are in conversations elsewhere in the country with other people about making this stage. And then we talked about the community partnership, and the community partnership is really the enduring. So we don't envisage the working group being too long a stage. We would like to move through and start to see some of the investment funding starting to flow to the community. And at this stage, we will start to gather new information, surface-based investigations. This is demonstrating aerial geophysics. But we'll start to gather some new information, not borehole drilling, but gather information to do an evaluation which will allow us to go forward with confidence into what is a fairly significant investment to drill boreholes to characterize the site. So these are indicative timelines, 5 years, could be 10 to 15 years. A lot depends on the geology, the nature of the geology, how easy it is to characterize or how complicated it is to characterize, but it also depends on the speed that the community wants to move forward. So sort of two controlling factors would be the level of technical work that needs to be done, but also going forward at a pace that the community actually want to move forward. So I'm moving the talk now a little bit more into the technical side. And I mentioned at the beginning of the talk, or fairly early on in the talk, our approach to site evaluation and what makes up a suitable site. And if you have a look at the document, we have in the document, you will see 6 sort of headline siting factors, and sitting below the siting factors are 26 evaluation considerations. So they start to pick up the detail. So those, and I know there are many in our audience tonight that have been involved in the mining industry. So this is akin to undertaking feasibility studies, little bit of a crossover with environmental impact work as well. So a little bit of a hybrid, but I think for those who have worked in mining, feasibility studies is a good surrogate for this. And we're trying to create a sort of a holistic evaluation of an area or a site that looks at safety and security. And, you know, this is always at the top of our list. Safety and security has to be assured. It's got to be assured by us through our safety cases and endorsed and by our independent regulators. And, you know, the bottom line is a GDF just will not be built unless both we and they are satisfied that it is safe to do so. It, you know, full stop. But the holistic evaluation seeks to look at this in a broader sense. It looks at the community. It looks at the sort of socio-economic opportunities that a facility could bring. It looks at community well-being, health impact, and it looks at how we can align the implementation of a GDF with that vision for the community. So, for example, you know, say an area was prone to flooding, and there was a big issue with flood management. How could we manage? How can we adapt the design to improve the overall flood resilience for the area, not just for GDF? So that's just sort of one example. It could be power resilience, it could be transport infrastructure, etc. But it's very important, and we're seeking to align this vision. Environmental impact is absolutely fundamental. This is a significant undertaking. You know, it's in mining senses, it's, you know, it's not a major mining undertaking. It's significant, but compared to many of the mines that we're familiar with and some of the tonnages that we produce, and you know, we go down the coast from our virtual lecture room to Sirius, and you know, we look at the sort of volumes that Sirius is talking about. You know, the GDF is so much smaller, and it's over a very long time scale. Clearly, we need to satisfy ourselves. Can we actually implement this? Is it feasible from an engineering point of view? Can we design it? Can we design it with that, you know, fully adopt sustainable design principles? And will we be able to construct it and operate it at a given location over that long length of time? I mean, my experience in Winsford, I guess a number of people will have visited Winsford over the years, but you know, when I was there, we'd been operating for about 160 years. So, you know, it can be done, but you need to consider that, you know, about that longevity. And a lot of our coal mines in the northeast were of that sort of age as well. Can we transport it safely? Can we transport the waste? Can we transport people and get people to the site? Can we move the spoil from the site or manage it properly? Can we bring construction materials in? So very holistically. And ultimately, this is funded by UK PLC. And, you know, we have a duty on behalf of UK government to secure value for money. So there's a sort of a, you know, that value for money calculation needs to be done. So that when we talk about a holistic evaluation, this is what we are talking about. Geology I mentioned before, and I talked about the different rock types. And I mentioned the National Geological Screening. So this was done in the run-up to the launch of the policy. It's a great resource. I would commend it to people if you are interested in these sort of things. There are regional reports. There's a sort of a national overview. We tend to talk about the higher strength rocks that I mentioned, the lower strength sedimentary rocks, the sort of clay types rock, the Mercia mudstones and Oxford clays and so on, and evaporites, you know, typically in rock salt. And I think this is a really important point, which I'll come back to in a second, is that particularly the policy this time around extends the opportunity to construct a GDF under the seabed. And you know, something that many in this room, I know Norman Jackson's in the audience, and we had many a conversation about this, you know, and undersea working. So working within the inshore waters, 22 kilometres from the coastline. So I think that's a very important point, and is a significant differentiator in terms of the policy this time around. I'm not going to dwell too much on this because there's quite a lot of detail. It's there for your reference, but this is really just sort of saying that site evaluation journey that I summarised before, that very early discussions, in the initial discussions, just quite a high level evaluation, principally focused on safety. It's a sort of a showstopper type test. And then moving into the working groups where we start to identify search areas, start to increase the level, but still using desk-based information. And then it's really here where we start to gather the new information. So you saw this image earlier, some sort of key points about a GDF. Surface facility. Ideally, if we were totally unconstrained and we wanted to lay things out in an optimal way, probably about 1 square kilometre to take all the facilities. And if you recall, when we talk about the facility, it's both the nuclear facility, the element to handle the radioactive waste into the facility, but it's also the construction element, the mining element, if you like, where so sort of 2 separate things combined on the site. So ideally 1 square kilometre. We have designs where we believe that we can implement, subject to the site-specific nature, down to maybe about half a square kilometre. There is plenty of opportunity to move some of these facilities off-site. So, if there were other locations, local towns, you can move offices and other facilities off-site. As most people in this audience will recognise, we connect the surface to the underground by inclined tunnels, drifts, or via vertical shafts, and that will depend on the configuration. This image shows the disposal areas sort of vertically below the surface, but it can be displaced, and we often talk 10, 15 kilometres away from the surface, which, in the northeast collieries, we were used to working at those sort of distances, so quite achievable. And I made the point that the facilities could be built onshore. We could be 22 kilometres offshore, away from the coastline. And, I think this is another key differentiator, that we recognise that coastal locations bring other transport options, away from rail, and start to bring sea transport into play for construction and other materials. And clearly spoil, although, it's, by mining standards, it's not large volumes. But it can be used for beneficial purposes, or, in this case, it's shown screening the surface facility. So that's the sort of broad, schematic of what a geological disposal facility would look like. A few facts and figures. I think we've covered quite a few of these already, so probably not going to dwell on these. But yeah, size. I think maybe that's one thing I haven't mentioned so far. The underground layout depends on whether it's sort of single horizon. It does depend on the geological setting, because some of the higher strength rocks would maybe have larger tunnels and vaults, whereas maybe some of the lower strength sedimentary rocks or the evaporites, depending on the depth that we were working, a little bit smaller in size. So of course that tends to spread the footprint out to accommodate the volume of waste. I think this is worth just saying for absolute clarity. The sort of 750,000 cubic meters of packaged waste that I talked about, the sort of forecast 750,000, this does include materials like spent fuel and plutonium. Now, for absolute clarity, these materials are not yet classified as waste. So some of this volume, some of this inventory is not yet classified as waste. And we were asked to also consider the implications of a future new build program. So it does also include 16 gigawatts of new nuclear. So we don't know if that's going to come to pass. There are some projects that are moving forward. We don't know what size that is. We don't know what final decision will be made about spent fuel, what final decision will be made about plutonium. But we, as the developer, are asked to plan for this, and that's what we do. So the presentation I've given this evening is on that basis. I think we've covered most of it. Probably this is a final key point on this slide. 99% of the radioactivity in the higher activity waste decays naturally to a safe level in less than 1,000 years. So rapid decay. But this is the issue, that some of the radionuclides and some of the radioactive waste does remain hazardous for over 100,000 years, which is why, you know, it's the whole rationale for you have to put this in a GDF that can be operated, closed and sealed and left in a state that doesn't require intervention over the very long term. So I think sort of the final slide for me, I've mentioned earlier the role of government, really in terms of setting the policy. Nuclear Decommissioning Authority is our parent body, our parent company, sets the strategy really for the overall management of radioactive waste that's coming from the decommissioning operations around the country. And we, as the implementer, are responsible for the design, the siting, the construction, the operation, and ultimately closing the GDF. And we will be the license holder for that. Quorum, the Committee on Radioactive Waste Management provides independent scrutiny and advice to government. So operates still very active, and I would recommend that you have a look at their site. We have the regulators. So I've picked out Environment Agency, Office of Nuclear Regulation, and NRW, Natural Resources Wales here. Got the Health and Safety Executive in here as well. And I mentioned Planning Inspector as well. Obviously not a regulator, but key to issuing consents for construction. And, you know, I think that terminology is probably not quite right, because ultimately we are responsible for the safety. RWM is responsible for the safety, and we do that through the development of a series of safety cases. We have to present our safety cases to the regulators, and they have to be satisfied that our safety cases are sound before they will issue the requisite permits and licenses. So this is, if you like, the regulatory checks and balances that goes alongside the consent-based process that I mentioned earlier on in the lecture. So my closing remarks, I would just like to say thank you again for the invitation and the opportunity to present what I think is a really exciting project. I think it's the right thing to be doing, and I think it's the right thing to be doing now. We are more than happy and willing to talk to anybody, and would welcome engagement outside of this lecture to explore this further. When I got my colleagues to just check these slides before finalising them for tonight, one wag said, of course, this was an image of me. I mean, the Institute members will recognise the image, so thank you for letting me use it tonight. But just rest assured, that's where I sort of did start my my career, albeit in the South Wales coalfield. I think I did wear a helmet, but I think it predated workwear. And I think we did have a cap lamp at the time. But yeah, Hanfield Stable on B103, deep navigation colliery back in the 1970s, props and bars, Hanfield Stables. So good times, very, very fond memories. And here we are 40 odd years later, still looking to excavate ground and do something useful with it. So thank you. I'm going to close the presentation at this point. I'll come out of the presentation. There are some links there that we'll provide through. So if you want further information or, you know, plenty of information on our website, you can follow us on Twitter if you want to. You can correspond with us. You can get our regular bulletin, so that information will be available to you after the talk. So I'm going to come out of here now, I hope. I'm going to stop sharing, and I'm going to hand back to our president. Back to you, Rick.
Oh, well, Steve, thanks. That was an absolutely splendid talk, and but very thought-provoking too. You've said that you and Bruce are quite prepared to answer questions. So I'm going to hand over now to Matt, who will open the floor to the audience to ask questions, and well, we look forward to an interesting Q&A debate. Matt, over to you, please.
Thank you, Rick. So if you're joining us on Zoom, if you would like to ask a question, could you please use the raise hand function, or use one of the other reactions, or you can get in touch with me through the chat function as well. If you're joining us through YouTube, if you could put your questions or messages into the chat function on the YouTube channel, and I will relay those to Steve and Bruce. Just before you ask a question, if you could please state your name and your location if you feel comfortable doing so. Okay, so I'm going to start off going over to John Beatty.
Yeah, thank you. Good evening, everybody. Thank you, Steve. Fascinating. I have a couple of, excuse me, couple of technical questions and then some social questions, if I may, very quickly. Why is bentonite clay? What are the properties of bentonite clay that make it so important in this process? Why is Scotland not following the rest of the world? Why has Scotland decided to do a near surface storage system when the deep storage seems to be the choice of everyone else in the world? The slide 14 was interesting. We're talking about the geology in it. You were suggesting that, in fact, there were geological opportunities all over the UK for communities, but are there in fact particular geological limits, geographical limits, because of the geology, that would make certain communities more likely to be suitable sites? And the communities themselves, you talked about opportunity, economic opportunity, and suggested there was a suggestion that a certain level of deprivation might attract a community to participation in this. So do you have criteria that about the kind of communities you'll be looking at that you haven't discussed? And I mean, I have no idea how many you're looking at, but just looking at the figures, you could be looking at what, 9 sites over the country. But anyway, that's not an awfully well-informed guess. And one more question, then I'll shut up. The 100,000 years is an awful long time, and if we go backwards from here 100,000 years, it would have been impossible for communities at that time to communicate certain issues in such a way that that society of today would be able to understand those issues. So there must be some interesting conversations going on about communication to societies within the next 100,000 years. Lots of questions, but thanks for a fascinating talk.
No, it's a pleasure. So I've noted sort of five sort of topics there. Bruce, I'll take the bentonite clay question.
Sorry, I ought to have said John Beatty Bedlington as well. We need to have Bedlington noted on this. I apologise.
Thank you, John. Yeah. So if I just take the bentonite clay question and the sort of geology and the exclusion criteria question, I think Bruce may be better placed than I to talk about the Scotland issue, the sort of economic issue, and whether deprivation itself would play a part, and really how do you signal the location of a site, or do you signal the site? So Bruce, are you all right to pick those up if I take the first 2 points?
Yes, yeah, you may just have to remind me nearer the time in case I forget one.
Okay.
It won't be intentional.
No. So I think we use the bentonite clay as an example, and maybe if I take us into higher strength rock, so a crystalline rock. So one of the things that is fundamental to the design and the long-term operation of a GDF is the hydrogeology. Is it a dry geology? Can water enter it? If water enters it, how is it going to move through the system? So if you were in a higher strength rock, we know that in granites, the absolute solid block of granite is dry. It's got very low permeability, but granite tends to have fractures and fissures, and over time, groundwater can penetrate. So bentonite clay in that circumstance is used, so it provides some buffering and shock resistance, if you like, around the waste packages. But if water contacts bentonite, bentonite has a unique property in that it swells. So it swells into the cracks and the fissures and any small void space that may be left between the package and the opening that had been created in the ground, and therefore further retards any inflow of water. If water eventually, moisture gets through, and our safety case then does a sort of a worst case and looks at corrosion of a package, and if there's a leakage from a package, bentonite then retards any flow of radionuclides coming back away from the package. And it also has what are called, we call them absorbing properties to attract radionuclides to it. So it retards any release of radionuclide. So it's just part of that barrier if you had a situation where there was water in the strata that you're implementing. We know that in clay rocks, salt rocks, although they have inherent moisture in, are in essence dry, dry rocks. So hopefully that answers your question, but you can place that bentonite in different ways. You can place it in compacted bentonite, really solid rings that swell. You can place it as pellets. In salt environments, you may actually use salt around the waste packages. So that's the bentonite story. The geology question is a really good one, your third question. And maybe I should have said this a little bit clearer, or should have said it in the presentation, so I apologise. So we've got the host geologies, but one of the things that we will look at in terms of the suitability of the site is what that, what's around that geology. Are there oil reserves, gas reserves? Are there coal reserves? Something that could, major aquifers. Is there something in that geological environment that is likely to cause that geological environment to be disturbed at some point in the future? Humans will want to go there. Or the ground may have been disturbed through historic coal mining, created fracture paths and so on, and therefore has disturbed the site. So absolutely, there are exclusionary criteria, and in the previous siting process, that was one thing that was done actually in West Cumbria. There were exclusionary criteria where reserves, mineral reserves or resources were present, or aquifers were present, or the ground had been heavily disturbed. So that's really the story behind that. I'm going to hand over to Bruce.
Sorry, can I just before you do that, does that mean that pretty well the whole of the northeast is excluded?
I think the coal mining areas are a challenge. We would need to look at it a little bit more closely. We tend to look at it when an interested party comes forward, John. Rather than going around doing a screening exercise of the whole country. We've got the NGS, But when a conversation starts, we tend to look at that. But the coal mining areas would prove a challenge. The areas that are not coal mine, we would definitely have a good look at.
Thank you.
Yeah. So Bruce, I was going to ask if you could cover the Scotland issue, the economic opportunity question, linking that to deprivation, and then, how on earth do we signal that we've implemented a GDF to people 100,000 years in the future?
Yeah, so I was just tapping a little note on a notepad on the screen so that I would remember all three subjects. So thanks for reminding me. I'll take them in Scotland, deprivation and communication, for no other reason than that's the order I wrote them down in. So Scotland has a different policy, but it's not actually a hugely different policy. So the inventory of waste that the Scottish policy covers is actually quite limited. They don't have any high-level waste from reprocessing in Scotland, and spent fuel from the commercial reactors that are there is not classified as a waste and is already under commercial contracts to go elsewhere, mostly to Sellafield, in fact, if not entirely to Sellafield, where the reprocessing and storage facilities are. And defence, of course, is not a devolved issue. So what you're left with are the reactor decommissioning wastes at the civil power station sites in Scotland, Chapel Cross, Torness and Hunterston. So that's a much smaller inventory, which lends itself much better to alternatives like near-surface disposal. And near-surface disposal has actually been looked at across the rest of the UK as well. The NDA have literally, I think just last week, published their consultation on their 4th strategy. And alongside that, they've published a paper on near-surface disposal, which they've also been asked to look at by UK government for England. And the original quorum recommendations reflected this point explicitly, that certain wastes, like reactor decommissioning wastes, may not need the levels of isolation and containment that geological disposal offers. So near-surface disposal has always been on the table, and the Scottish policy focuses a lot more on that more immediate challenge that they have with reactor decommissioning materials. It's also clear that there is some stuff in Scotland, principally at Dounreay, which will not be suitable for near-surface disposal, and they recognise that. And their policy calls for further work to be done before they make their decision on what's going to be done with that. So their approach has been to focus on the things that are closest to them, and more work to be done on the little bits that are left that, in the case of Scotland, are a smaller part of the inventory. Deprivation social criteria, let's call it that. Under the policy we've got, we're not seeking to impose this facility anywhere in the country, and we're not targeting places on the basis of deprivation, but there are places in the country that are more likely to be interested in this sort of large-scale industrial development. So, whilst we are open to discussing this with absolutely anybody, you'd have to say that national park maybe, or areas of outstanding natural beauty, very rural areas, might not be as interested in a development on this scale as places that are more used to dealing with large industry, energy developments, things like that. So that will be a factor, and that will be taken into account as part of Steve's site evaluation factors that we talk about. And that will play out in the discussions that we have with local authorities and others all around the country. In terms of the long-term communication issue, this is an incredibly interesting point. And it is a field where there's a lot of study going on and a lot of collaboration internationally as well. So the first thing to remember, of course, is that the waste already exists, and most of it already exists. So we're either going to leave it on the surface, or we're going to place it deep underground. And in these future scenarios where communication has broken down, society's broken down, people don't speak English anymore, things like that, the alternative to having it underground is having not just the fact that people can't read the records at the surface anymore, but they've also got the waste sitting right in front of them and they don't understand what it is. So that's always going to be worse than having the material deep underground and having records that somebody can't read about it. But there is still this really interesting work going on about how we can nullify that risk of communication failure by looking at other ways of communicating into the future. And the NEA, the Nuclear Energy Agency, have already done quite a lot of work on this internationally, and there's new work just been started recently. Within the UK, the NDA has the Nuclear Archive, which is based in not based in Dounreay, it's based in Caithness, just outside Wick. And they are doing a lot of work as well alongside ourselves on how records can be retained, but not just records, also the knowledge that underpins them, so that people actually know what they mean and can understand the importance of them and how they relate to each other. And there are all kinds of pieces of work being done on this. You might have heard of some of it. Things like producing, creating a landscape above a disposal facility that inherently looks threatening. So that in the scenario where all language has been broken down or has been replaced by something else, human beings will just naturally feel threatened by this particular design of landscape or sculptures. There have been talk in the past of the nuclear priesthood. I particularly like that one. I spent some time in the States talking to some First Nations leaders in Canada and in the United States, where they themselves have said, you know, we have knowledge that goes back thousands of years beyond when Europeans came here, and it's been passed down by word of mouth. You know, we will pass on this information. We will continue to tell the next generation and the next generation. So there is something in oral tradition as well. And I actually know there's some work being undertaken with other academic areas, not related to engineering or nuclear, but things like Egyptology even. So people who have experience of trying to interpret information from the distant past in human terms. What can they tell us about how we need to communicate with humans in the distant future? So it's an enormously interesting area. But the bottom line always comes back to, it's still safer to have the material isolated underground than it is to have it on the surface over those timescales.
Thank you.
Thank you. So I think we have a question from Norman.
Yes, thank you. I noticed with interest the international collaboration that you showed. There was two big players appear to be missing from that, unless I didn't see the flags properly, and that's the Soviet Union, like the old Soviet Union, Russia, and China. Is there any, of course they are the big players as well in the nuclear scene, is there any information passing from them in what they ultimately decide to do?
So I may call Bruce in again on this. I know Bruce is probably better placed than I, but I know that there is some collaboration with China. I know that one of our colleagues has been working with them on site characterization recently. So Bruce, do you want to just pick up on that?
Yeah, so both Russia and China are also pursuing geological disposal. The Russians are part of the Nuclear Energy Agency and IAEA, so through those bodies, lots of information can be shared backwards and forwards. I've actually been on a site visit to the Swedish underground laboratory with a team from Russia who happened to be on the same trip as well, which was an interesting few days. And they have a program set out which you can access through the NEA's website. That will set out what the state of play is in Russia, but it's geological disposal, and they've got their own program in place for identifying and characterizing sites. China, not currently a member of NEA, but NEA and China are working more and more closely together. I was actually due to attend the first NEA China conference in Beijing in February this year, which unsurprisingly was cancelled for obvious reasons. But the Chinese are also pursuing geological disposal, and in fact have identified a site, I think on the edges of the Gobi Desert, yes, which has been is being characterized, and some of our people from RWM have been out there on exchange visits getting involved in that work as well. So there is information transferring backwards and forwards. I think Steve probably just highlighted a few of the leading countries around the world, but every country that has a nuclear program and has made its decision on what to do with this category of material has decided that they need to have geological disposal. So there are lots of other things we can do, like near surface disposal, possibly boreholes, reprocessing can change the character of some of the wastes, but there's no version of the future in which we don't still need to have geological disposal.
Thank you very much. The reason I asked that question is that I did a lot of work in Russia and in the Baltic areas, and to see some of the storage of the nuclear stuff there from the naval scenario leaves you quite cool. And of course, public consultation isn't a feature in either of those two countries. They will decide where to put it, and that will be the site.
There are many interesting decommissioning challenges in Russia. They've, of course, inherited a vast amount of facilities and materials from the Soviet era, which are now being dealt with.
Thank you. Norman Jackson, Seton Sluice.
Very much, Norman. If anyone else on the Zoom call does have any questions, please do raise your hand or use a reaction. I've been emailed a few questions from Gordon Liddell, who joined us through YouTube, and I will just read these out. They are, question 1 is, how will the depositories be monitored? Question 2 just says water contamination issue, but I'll leave that up to you as to how you answer. And the third question is there any prospect of working with the Yorkshire evaporite companies? And that's all from Gordon Liddell.
Yeah, so similar, if I just take a couple of these, probably take each of these and conscious of time just to move through. So Gordon, thank you for those questions. Similar to Bruce's previous answer, monitoring a GDF is almost a topic in its own right. And it's actually a very good example of collaboration projects. You know, there's a European collaboration project called Modern, which is all around monitoring. And there are all sorts of challenges in terms of the radioactivity, the longevity, how to keep power supply, how long do you monitor for at the point of closure, because ultimately you can't, you can't go and replace sensors eventually. So basically, there is a specialist field, and we could get, it's probably too specialists to go into tonight, but a variety of monitoring devices in terms of the underground environment to provide that telemetry back, so particularly through the operational phase, that you are satisfying yourself that the facility is behaving as you anticipated. That's what this is really about, as well as the normal sort of day-to-day worker protection, monitoring, and so on. The water contamination issue, without being able to have the conversation, I'm not quite sure whether that's a sort of a water contamination issue through construction, so as we would consider in any mining project, what is the impact of the construction and operation of the facility on groundwater, whether it's used as an aquifer or not. So it's incumbent upon us to do that. But the basic premise, as I alluded to in the earlier conversation that we were having, question around bentonite, is fundamentally we are looking for sites that are dry, in inverted commas, or if there is hydrology present, that it's a very slow moving, passive type environment. Bruce, you're a geologist, and you may want to just come back on that. The prospect of working in the evaporites in the northeast, I mean, I think it is a very interesting disposal environment, and it would be certainly one that RWM would welcome having a good look at. But because of the consent-led process, we almost need somebody to sort of trigger that conversation. So yeah, absolutely. I think, you know, salts and evaporites are good host environments. But, you know, as I said in the talk, you can modify and you can make, by modifying the engineered barriers, you can implement geological disposal in many different environments. So, Bruce, do you want to just pick up on the hydrogeology issue, please?
I think the only things I would add to what you've already said, Steve, are just a quick note that we don't tend to be looking for existing mines, so the existing salt mines, for example, for the reason that everyone here will understand. Of course, the mines are constructed for a different purpose, and the object is usually to get as much material out as possible, whereas for our purpose, we're looking to take out the minimum amount of material in order to leave the most behind to act as the buffer and the protection and the isolation. And there are examples that are often brought up in public meetings from overseas. Within Germany, for example, they used there was an old salt mine that was repurposed to put waste in, and it had in a salt diapiric formation. And the mining operation had got too close to the edge of the salt, and at some point water had broken through. So there's now water flowing through salt, which is not good. And there's a load of radioactive waste in it. And the Germans are now having to look at how they remediate this situation to get material back out of it. And this is a real problem that's actually happening right now in one of these scenarios. So the fact that there are mines somewhere, we probably wouldn't want to be going and repurposing those mines, but the fact that there is salt may mean that there is other geology nearby that might be worth us looking at. On the groundwater issue, of course, the purpose of the GDF is to isolate and contain this material. So the years of work that we'll do on site characterization, a large part of that will be about ensuring we have a sufficient understanding of the geological environment, including the hydrogeology, to be confident that there is not connectivity between our material and the potable drinking supplies, which tend to be at a much shallower depth. So we're looking at either zero or incredibly slow return paths for any fluid that manages to get through our facility at depth. We want to make sure that fluid is not returning to the surface. And that's going to be a large part of what our site investigations look at.
Great, thank you very much. I think we've got a final question, perhaps from Steve Martin. Just asked to unmute. Steve. Sorry, Steve. Yeah.
There. Hi, Steve. Thank you very, very much indeed. That was an absolutely wonderful lecture, and you know, it makes us people in 2020 feel very, very safe for our futures, at least. And I'm happy to say that that you are looking at this very, very carefully and being very, very precise in where and when you are going to open these facilities. It just crossed my mind, though, that in quite a lot of mining activities that happened 200 years ago or so, that we are now going back to them with new methods of finding the materials that we couldn't use before. And is there, I know you're saying 1,000 years, that's a long, long time. Do you feel that perhaps even in 200 years, there's a possibility that there may be going back to your facilities to reuse the equipment or the materials that are down there for a future use?
Yeah, it's a great question, and to sort of give it its sort of technical terms, retrievability, reversibility, recoverability are terms that get used, and again, you can do you can almost do a master's degree on or a PhD on this. So it is a big debate, and I mentioned in my talk about the evaluation considerations that sit under the siting factors. So one of those evaluation considerations is exactly that. It's about retrievability. And linking it to what I said about the inventory, some of the waste at the moment is not declared as inventory. And this is a debate that gets played out. So, you know, spent fuel, is it a resource or is it a waste? And decisions, final decisions haven't been made on that yet. But they will be as we go through the siting process. I think the position that we take, and sort of I recognise this as a mining engineer, is that there is the opportunity to recover, retrieve the material that is placed on the ground when it's operational. It becomes increasingly difficult as time goes on and you start to seal tunnels and vaults. Not impossible, but it becomes increasingly difficult. And then when you ultimately seal the facility. So it's probably not a definitive answer, because I don't think we have a definitive answer. My closing comment, and I will ask Bruce just to add to this, but my closing comment is, I think it is important to recognise that our remit is to dispose of the material that is agreed to be disposed of. So that sort of presumes that you go through that logic first. But I totally take your point, and it is a debate that comes all the time. But our remit is to design a facility to dispose of material. That's the key point. If we just got time, just add, Bruce, because I know this is one of your specialist topics also. Is there anything you would like to add to what I've said?
No, there are categories of material that some people think are waste already, like spent fuel. You'll hear quite a lot of sort of modern innovative reactor vendors, particularly small modular reactors as well, sometimes talking about how they can burn waste. Their new reactor design will burn radioactive waste. It doesn't. What they tend to mean is spent fuel. And even then, usually they tend to mean you take the spent fuel, you reprocess it, you extract the useful bits, and then we use that for fuel. But we have large amounts of industrial waste, this intermediate level waste, that we have the high level waste that's been extracted from previous reprocessing, and these just don't have a use. The other material like plutonium, uranium, spent fuel is still up for debate. So if the definition of waste or radioactive waste is radioactive material that has no further use, then there are still some things that are in that grey area where they might have a further use. And that's a decision for government and the owners of the material, because there's always a cost attached to everything you do, and there'll be a question around whether it's economic. And if you're talking about things like plutonium, then there's the security issues as well. So government's trying to weigh this up. What's the best thing to do with this material for the country? It's a strategic stockpile, but it's a security risk at the same time.
Thank you very much. We'll just hand back over to Rick.
Steve, Bruce, thank you very much for answering those questions. And thank you everybody for asking the questions. I wish there'd been more time. I'd have liked to ask about ice ages and sea level change. I mean, I don't disagree for a moment about underground being the best place for it. But I think we're going to have you back another time to ask about the really long term and protection. But now I'd like to hand over, please, to Andrew, who's going to give the vote of thanks on behalf of the Institute. Andrew, over to you.
Lovely. So thank you very much. So I must say our speaker tonight has provided a great overview of this topic, and certainly those who tuned in to see the Northeast Regional Final of the fantastic IIMM Young Persons Lecture Competition last week would be familiar with many of the topics he's covered in terms of the multi-barrier approach for radioactive waste. He's provided a summary of the wide range of lithologies these facilities can be hosted in, and as he points out, it's not just these old granitic cratons that most tend to crop up in conversation most of the time. And he's also highlighted the importance of hydrogeology of these sites. along with the work of our own excellent British Geological Survey, and even just a quick look at the National Geological Screening documents that they've come up with shows that they're very comprehensive and professional, and I'd certainly say do have a quick look at those if you can. The other excellent point was the flexibility of these facilities in terms of both the future makeup of any radioactive materials that might come into them and the future proofing of facilities from disturbances, either physical disturbances or of course human activity in various forms. But equally important to this is the underlining of the importance of the community consent, even down to the exploration boreholes. And it's excellent to see the amount of work that goes into that, and working with local communities and assessing the benefits that they may receive from this work. And I'm sure I speak for everyone, as Rick has just said, that we'd be very glad for both Steve and Bruce to return to the Institute in the future to give us an update on the progress of any of these projects that may take place. So if I'm not sure if Matt would like to unmute everyone, but certainly if we could show our appreciation to both Steve and Bruce in the usual way. So